In earlier times, there was the junk man. He knew that one man's trash could be another man's cash. We must learn that what we throw away today contains the resources we will need tomorrow. Today's junk man is often a member of the environmentally conscious younger generation who has joined a recycling campaign. These young people are taking part in an innovative campaign against contamination and to help conserve a valuable resource. They are paid 10 cents a pound for returned aluminum cans. Collection centers for reclaiming cans are being set up wherever aluminum cans are used in large quantities. The reclaimed cans are delivered to a processing plant for recycling, one of industry's methods to help combat the solid waste crisis, an effort encouraged by the Environmental Protection Agency, charged with the responsibility to increase recycling, reuse, and recovery of solid wastes. These ingots of aluminum have been formed from recycled material. They are rolled into sheets of aluminum to make new cans, which are then reused. Unfortunately, the present economics of recycling leave much to be desired. But with the refinement of recycling methods and the development of new markets, we can reclaim resources and improve our environment. This recycling operation in San Diego is reclaiming 2 million cans a month. Collections from all aluminum companies nationwide will soon bring the total to nearly 200 million a year. But with 5 billion aluminum cans manufactured a year, it's only a drop in the bucket, or more precisely, the garbage can. If there's a dump in your town, what's being done about it? In this age of Aquarius, dumps should be as obsolete as the Pony Express. Yes, the overall problem of solid waste management is enormous. Municipal, commercial, and industrial waste amounts to 1 million tons a day, and the tonnage rises every year. Incinerators are used to reduce the volume of refuse, but the old-fashioned incinerator creates air pollution, so it is not much better than a burning dump. Even new incinerators that are equipped with air pollution control devices cannot do a good job when they're overloaded. They merely scorch the wastes, leaving large quantities of unburned combustible material in the residue that must be buried. The most widely used acceptable method of solid waste disposal today is the sanitary landfill, where refuse is compacted and buried. Garbage can be protected from birds, insects, and rodents by applying earth cover quickly. Water pollution can be prevented through careful landfill design and operation. But burying all our wastes is still not an ideal long-range solution because valuable land is needed, and everything that is buried is essentially lost for all time, withdrawn from the resource cycle. In these days of environmental crisis, the American public expects our technology to provide the most effective systems for solid waste management. Burning or burying our reusable resources or strewing them about the countryside is literally wasteful. Increased recycling will provide the means for recovering and reusing more of our resources. Junked cars can be turned into high-grade scrap steel. Processing plants like this one on the West Coast have been doing it for only a few years. A huge claw lifts a doomed car onto a conveyor for its final journey. To misquote the Bard, these cars are getting ready to shuffle off their mortal coils. They've come full round from the assembly line to the disassembly line. These are stripped hulks, the auto wrecking industry has removed motor, battery, radiator, and other saleable parts before these bodies are chewed up by the shredder. Rube Goldberg might have designed this enormous shredder with an appetite for 1,000 cars a day, covering half a city block, costing several $millions. Today's mechanical shredder is able to separate steel from all other materials in your old car, converting it into high-grade pulverized steel. For many years, the hydraulic baler has been used to compress scrap metal to save transportation costs. When selected materials are baled, they constitute readily saleable scrap. However, when car hulks are baled, the resulting bundles vary in content and therefore have a limited market. Today, the salvage industry is entirely a private enterprise venture, producing a secondary material which has to compete favorably with virgin materials in the open market. Recycling this mammoth mess of metal boggles the mind. It will take the know-how of private industry, the cooperation of local, state, and federal government, and concerned citizens to shift this scrap cycle into high gear. Glass manufacturers have launched a campaign to recycle their products. The objective, to salvage an estimated 11 billion glass containers a year. This collection center in Lakewood, California, offers a penny a pound for bottles and jars. An important concept is being tested. Will citizens cooperate in recycling campaigns? 150 organizations have participated in this drive that has seen more than 3,000 youngsters bring in 100 tons of glass in a period of 8 weeks. If clear and colored glass are mixed and reprocessed, they produce glass that is a dirty shade of gray, so unattractive that few users will buy it. However, after the various colors are sorted and separated, the glass can be crushed and the cullet recycled into attractive new containers. The method is not new with the industry. Rejects have always been recycled, but only recently has there been a significant attempt to recover and recycle used glass. The glass industry has met the competition of the no-return can with the no-return bottle. From a solid waste management standpoint, the results have been disturbing. The deposit bottle, in its heyday, was reused an average of 20 times. But the forecast is that by 1976, 45 billion glass containers will be produced annually, and the deposit bottle will be obsolete. To solve this problem, the glass industry and retail establishments will have to consider reuse through the returnable bottle or recovery by large-scale recycling. The old proverb says, "Waste not, want not." These culled peaches from canneries are waste, part of the annual 2 billion tons of agricultural wastes of all types. What's going to happen to these peaches? They're going to be ground, pumped through a pipeline, loaded aboard a barge, and dumped into the Pacific Ocean. But we have come to realize that our oceans are not limitless, and using them as a dumping ground is not a peachy solution. In contrast, the oranges at this cannery will not only be used for juice, the peelings and pulp will be converted into animal fodder. Most oranges today are squeezed in the cannery, not the kitchen. This cannery is preventing pollution by making byproducts from the squeezins. Every agricultural processing industry has listed waste management as its major problem. With emphasis on curbing land and water pollution, the need for eradicating flies and odors, methods must be found to reuse agricultural waste more effectively. As in this instance, converting orange peelings and pulp into animal fodder. Contented cows and happy ecologists. At Johnson City, Tennessee, a federal demonstration project is undertaken to evaluate whether it is practical to compost refuse. Here is the process. All types of refuse are brought to the plant. Any large items which could not be handled by the plant equipment, such as metals, large bottles, plastics, are manually removed. The rejects are hauled to the landfill. About 25% of the refuse is rejected. The remainder of the refuse is moved on a conveyor to a grinder. 35 tons of municipal refuse a day was trucked to the composting plant for processing. Another hard-to-dispose-of solid waste, sewage sludge, from the Johnson City Sewage Treatment Plant is added to the ground refuse. The water is removed from the sludge, and the dewatered solids are mixed with the compost. The end product of composting is a humus-like material which can be used as a soil conditioner. The compost is laid out in windrows. The process takes about 42 days. The windrows are turned regularly, much as any good gardener turns his own compost heap. But composting has its shortcomings. There is no profitable market. Bits of glass, plastic, rubber degrade the final product, and complex, costly equipment is necessary. In many sections of the country where the land is barren, the compost could serve a useful purpose by retaining soil moisture and stimulating plant growth. Despite its shortcomings, composting is still a good recycling method for organic wastes, and every possible avenue must be explored to discover better methods for better living in a better environment. To recycle solid wastes effectively today, you have to be able to separate discards mechanically. That's the purpose of the Zigzag Air Classification Unit, developed by the Stanford Research Institute. The Environmental Protection Agency is sponsoring this project, which is attempting to perfect a practical system to separate paper, wood, glass, and metal. The system uses a blower, drawing air up a column and through a cyclone separator. Light material moves upward through the column to a receptacle, and heavy material, which cannot be transported in the airstream, falls to the bottom of the column. The zigzag separation method promises to be an efficient type of classification system. The air classifier has many possibilities for preparing refuse for composting and landfilling. Sharp, clean separation of solid wastes is particularly applicable for recycling, a potential that should be explored to the fullest. Bagasse, the remains of the sugar cane after the juice has been removed, is the basis for a reuse project. At Louisiana State University, research sponsored by the EPA is underway to convert cellulose waste into high-protein animal food, and possibly for human consumption. The pilot plant should be capable of producing protein from bagasse at the rate of some 75 pounds a day. Someday you might be asked to please pass the bagasse, but at the moment, the prime objective of the LSU project is to produce protein for animal consumption. What if we could burn refuse to develop heat energy? We'd have a dual advantage: generate electricity, dispose of solid wastes. The Environmental Protection Agency is exploring that possibility with the CPU 400, a turbo-electric generator plant that will be designed to use 400 tons of refuse a day to produce up to 15,000 kilowatts of electric power. This too is a form of recycling, converting waste into useful energy. In Madison, Wisconsin, recycling was put to the test when local authorities asked residents to bundle newspapers separately from other solid wastes. Sanitation trucks were equipped with special compartments for newspapers. And now the city is participating in a successful recycling project, from newsprint to newsprint. Sanitation engineers had questioned whether urban citizens, busy with their personal affairs, would balk at the additional chore of separating newspapers and tying them. Madison proved that citizens will cooperate. Instead of burning papers, adding to waste and pollution loads, the citizens of Madison are helping to conserve a valuable resource, particularly when you consider that paper represents almost 50% of the usual municipal refuse. Each of us uses an average of 575 pounds of paper products a year. This recycling process was made possible by a newspaper reporter who developed a method for removing ink from newsprint. His company, which is participating in this newspaper collection project in Madison, is supplying many newspapers with recycled stock. But recycling mills are few and far between, and only about 5% of newsprint is being reused. One recent development, the President has instructed the General Services Administration to review all federal specifications and revise them to permit the maximum inclusion of recycled fiber in the many grades of paper the government purchases. New and better solid waste management systems must be developed. Here at Middletown, Ohio, a demonstration project tests the effectiveness of a wet grinding system. The input is ordinary municipal refuse, cans, bottles, everything. The objective is to recover useful material from trash, paper fiber, glass cullet, and ferrous metals. The method is to dump raw refuse into a hydropulper, which disintegrates the refuse. Fibrous materials from paper and cardboard are reclaimed with equipment similar to that used in the paper industry. This rejected material will be burned in the fluidized bed incinerator. Future large-scale operations could use this heat to generate electric power. The junk ejector removes heavy metallic objects. Further processing can segregate reusable ferrous metals. The slurry is pumped through a liquid cyclone, which removes particles such as broken glass, sand, and small pieces of metal. This pilot plant is a prototype for systems that could be established nationwide. The first full-scale hydrodisposal system is being installed in the town of Franklin, Ohio. Like the pilot plant, it is designed to reclaim paper fiber, magnetic metals, aluminum, and glass. This big fluid bed reactor will burn all unreclaimed soft material at the end of the process. The U.S. Environmental Protection Agency is helping to pay for this $1.75 million plant under its demonstration grants program. A model regional sewage treatment plant is about to be built here next to the Solid Waste Reclamation Center. The solid waste plant will get processed water from sewage effluent and will burn sewage sludge. There will also be industrial cooperation. The reclaimed paper pulp from Franklin's refuse will be bought by this nearby roofing materials manufacturing company. Franklin citizens will still have to pay to dispose of their solid wastes, but some of the expense of this superior system will be paid through reclamation. Recycling our wastes is fundamental. Conserving our resources, minimizing the expense and difficulty of solid waste disposal. But effective large-scale recycling will require some basic changes in our society. Manufacturers, packagers, and retailers must be willing to modify their products and processes to meet recycling requirements. Government at all levels must cooperate to provide new equipment and better systems. Citizens must insist on recycling as a way of life. We must inject as much creative energy into recycling our products as we do in producing them.